So now I'd like to introduce Sai. Sai's got a Bachelor of Engineering, Master's degree of Environmental Management, and Sai and the team were looking for a cost-effective way to get corrections for their DJI M350 and hyperspectral camera workflows. So I'll hand over to Sai to go through her case and introduce herself.
As Brad mentioned, I work with Nallawilli Bunjil, and today I'm here to share our journey from going from like a frustrating 10-meter error to survey grade accuracy and how we managed to achieve this, all while also saying that I don't have any background in surveying. So yeah, before we get started, we're Nallawilli Bunjil. We're an Indigenous-led company, and we're also Supply Nation certified, and we work in remote sensing and analytics. We work in the space of LiDAR, photogrammetry, as well as hyperspectral, which is our new venture, and we do all of this through drone data capturing. And some of the use cases that we work on is land management and AI-based monitoring and conservation. So when we started off, we have our good old DJI drones, and we started off with the DJI RTK, thinking, hey, it's DJI, what could go wrong? And yeah, just when we were asking ourselves that question, we saw that everything could go wrong because the DJI RTK had its own limitations. And once we processed all of our captures, we noticed that we had like a whopping 10-meter inaccuracy. And that was something we didn't expect to see with DJI RTK. And then we thought, okay, we really have to fix this because we run detection models and AI models and a lot of machine learning algorithms. And in this case, spatial accuracy is something very important for our use case. And so we switched to the to a GNSS receiver, and we got the RS2 first, and we combine this with our hyperspectral data capture. So we use a Headwall hyperspectral sensor camera, and we make sure that we're mapping every pixel to every type of species that we find on the ground, which we use for our species detection models and also monitoring different types of species in peatlands. So that's why our spatial accuracy is very important to us. And when we use this, initially, we use this in RTK setup, and we still got our accuracy, and it was definitely way better than the DJI RTK setup. This is like some of the orthomosaics that we built using our hyperspectral cameras. And what we also realized was that when we're looking to expand and run these AI detection models, we also need to layer it with other kinds of data that we capture through LiDAR sensors, as well as photogrammetry that we use for labeling and identifying different species. So now that we have different types of data that we're overlaying on each other, we had to make sure that we had this centimeter level accuracy, which is when we brought this challenge to Brad, and Brad suggested that we switch over to a PPK methodology, or the post-processing kinematic. To post-processing kinematic, or like switching to PPK, was definitely a game changer for us because we were able to take because we're doing all of this capture in very remote areas where like we barely get any kind of cellular reception. So what we could do was plug the GNSS receivers, and we had our rover collecting points, and we were receiving these corrections, and would make sure we were able to take this back to our office where we had like our stable internet connection, we had like our computing power and everything. And since I'm someone who deals with everything post-processing and all of the analytics later, it made my life way easier. And as someone with like zero knowledge of surveying or anything or any kind of field experience in that matter, the Emlid app itself was very easy to use, and even the rovers and the base station setup was very easy because you had the app on hand, and it was something and also because we have Indigenous and First Nations rangers who are handling these equipment, it has been quite easy for them to use, and it's very user friendly, and the app has also been great. So it's more like you just plug it in there and you have it logging your data, and then you can take it offline and work with this data. And so that's why Emlid really works for us, and we were able to integrate it into our workflow because it's easy to use, and if I can do it, I feel like anyone can do it. And also the workflow is very easy. So you just have it when you're capturing your data and it's logging your data, and then you export it to any format that is easy for you to use. For example, for our workflows, we're able to export this into our software that we use. We're using Metashape or QGIS or our hyperspectral workflows with Headwall. And we're able to integrate this data into any of that, or even POSPAC and so on. So this made this whole process very seamless and easy. And that way, yeah, we were able to switch from our 10-meter inaccuracy to get our centimeter level precision accuracy and in our geospatial data. And that now we're able to use these orthomosaics and all of these data to run AI detection models and machine learning models for monitoring and so on.